Now, we need to count on in ones from a 4-digit number. So here, we start with 4095. So that's 4 thousands, no hundreds, 9 tens, and 5 ones. Next, we have 4096, then 4097. If we keep on adding ones, we get to 4098, 4099, then 4100. Now this doesn't look like 4100, but notice now we've got 10 ones, and we can exchange 10 ones for one more 10. So now we've got 10 tens, but we can exchange 10 tens for 100. So that's why one more than 4099 is 4100. And then we can keep on adding ones until we get to 4104. We could also show place value counters. So again, we're starting with 4000, no hundreds, 9 tens, and 5 ones. If we keep on adding ones, now we've got to 4099, but if we add another one, we get 10 ones, and we can exchange 10 ones for 1 10. But doing that means that we now have 10 tens, and we can exchange 10 tens for 100. So that's why we get 4100, and again we can keep on adding ones until we get to 4104. So now this time we start with 2997. So that's 2 thousands, 9 hundreds, 9 tens, and 7 ones. Then we have 2998, 2999, and adding another one gives us 3000. That doesn't look like 3000, but remember, because we now have 10 of these ones, we can exchange 10 ones for 1 10. But now we have 10 tens, so we can exchange those for 1 extra 100, and doing that gives us 10 hundreds, and we can exchange 10 hundreds for 1 more 1000. So that's why one more than 2099 is 3000. And then we can keep on adding ones until we get to 3006. We could also show place value counters, so again starting with 2997. If we add ones, we get to 3000, because if we've got 10 ones, we exchange those for 1 10. Doing that means that we have 10 tens, and we can exchange those for 100, and then because we've now got 10 hundreds, we can exchange those for 1 extra 1000, giving us 3000 altogether. And then we can keep on adding ones until we get to 3006. Now we need to add a single digit number to a 4-digit number. First, we have 6098 plus 5. Well, if we add 2, that will take us to 6100, because we know 98 plus 2 is 100. But that's adding 2, and we want to add 5, so we need to add 3 more. And that gives us our answer, 6103. Now, 5636 plus 8. Well, we know our number bonds to 10, so we know that if we add 4, that will take us to 5640. And adding 4 when we want to add 8 means that we need to add another 4 to give us our answer, 5644. Now notice, if you know that 36 plus 8 is 44, you know 5636 plus 8 is 5644. Now 2994 plus 9. Well, adding 6 will take us to 3000, because 4 plus 6 is 10, but we already have 9 tens in our number and 9 hundreds, so it's the thousands digit that needs to change as well. So that's adding 6, and if we want to add 9, we need to add 3 more to give us 3003 as our answer. And now 3993 plus 7. That gives us 4000, because 3 plus 7 is 10, but in our number we already have 9 tens and 9 hundreds, so the thousands digit needs to change as well. Now let's take a closer look at these questions. So first we had 6098 plus 5, and we can show what's happening with base 10 blocks. What you need to remember is that when we get 10 ones, we can exchange those for 1 10. When we have 10 tens, we can exchange those for 100. So starting with 6098, we can add 1, 2, then exchange. Then add 3, 4, 5, and you can see that we now have, because we've exchanged, 6 thousands, 100, no tens, and 3 ones. Or, showing place value counters instead, we start with 6098, we can add 1, 2, exchange, exchange again, then add 3, 4, 5 to give us 6103. Our next question was 5636, which we can see here. So we can add 1, 2, 3, 4, exchange, then add 5, 6, 7, 8, and that gives us 5644 as our answer. Or using place value counters, we can add 1, 2, 3, 4, exchange, then add 5, 6, 7, 8, and we get 5644. Then we had 2994 plus 9. We can add 1, 2, 3, 4, 5, 6, exchange, exchange again, and now because we've got 10 hundreds, we can exchange again, exchange those for 1000, and then we just have 3 more ones to add to give us 3003. Or using place value counters, we start with 2994, we can add 1, 2, 3, 4, 5, 6, exchange, exchange again, and because we've now got 10 hundreds, exchange again to make 1 extra 1000. So we've added 6 to make 3000, so if we just add 3 more ones, that gives us 3003. Then our last question, we had 3993. We were adding 7, and when we do that, if we add 1, 2, 3, 4, 5, 6, 7, we get 4000. Now that doesn't look like 4000 at the moment because we haven't exchanged, but we do now have 10 ones, so we can exchange those for 1 10. Now, because we have 10 tens, we can exchange those for 100, and finally, because we've got 10 hundreds, we can exchange those for 1000 to give us 4000s altogether. Or if we show place value counters, starting with 3993, we can add 1, 2, 3, 4, 5, 6, 7 to give us 4000. Again, that's 4000 because we can exchange 10 ones for 1 10, 10 tens for 100, and 10 hundreds for 1 more 1000. And that gives us 4000s altogether. Now we need to count on in tens from a 4-digit number. So here we start with 5,476. So that's 5 thousands, 4 hundreds, 7 tens, and 6 ones. If we're counting in tens, we're adding 1 10 each time. So adding another 10 gives us 5,486, then 5,496. But if we add another 10, now we've got 10 tens, and when we have 10 tens, we can exchange those for 1 extra 100. So that means we get 5,506, because now we've still got 5,000, but we've got 5 hundreds, no tens, and we still, of course, have 6 ones. Then we can keep on adding tens until we get to 5,566. So that's 5 thousands, 5 hundreds, 6 tens, and 6 ones. Notice, because we're counting in tens, the number of ones that we have will always stay the same, but the number of hundreds, like we saw here, might change. We can also show counting in tens using place value counters. So again, we're starting with 5,476. If we count in tens, once we've got 10 tens, we can exchange those for 1 extra 100. So that's why we go from 5,496 to 5,506. So adding 10 means we go from 9 tens to 0 tens, but that's because our hundreds digit has increased by 1. And again, we can keep on counting in tens until we get to 5,566. So now here we start with 6,964. So there's 6 thousands, 9 hundreds, 6 tens, and 4 ones. If we're counting in tens, we can add 1 10 each time. So doing that gives us 6,974, 6,984. Another 10 means we get 6,994. But adding one more 10 takes us to 7,004. That's because we now have 10 tens, and if we have 10 tens, we can exchange those for 1 extra 100. But doing that means that we now have 10 hundreds altogether, and if we have 10 hundreds, we can exchange those for 1 extra 1,000. So, because we've added 10, we now have no tens, no hundreds, but we've made 1 extra 1,000 because we've exchanged. And of course the ones digit, as always when we're adding tens, stays the same. Then we can keep on counting in tens until we get to 7,054. So that's 7 thousands, no hundreds, 5 tens, and 4 ones. We can show place value counters for this question as well. So we start with 6,964. We're counting in tens, but when we get 10 tens, we have 7,004. That's because we exchanged 10 tens for 100, and then because that gives us 10 hundreds, we can exchange those for 1 extra 1,000. So because we exchanged twice, adding 10 means that we now don't have any tens or hundreds, but we do have 1 extra 1,000. Now, if you know that one more than 699 is 700, then you know that 10 more than 6,994 is 7,004. You can see if you ignored the ones digit, you would have 696, 697, 698, 699, 700, 701, and so on. So counting in tens with 4-digit numbers is just like counting in ones with 3-digit numbers because our ones digit stays the same. So here we can keep on adding tens until we get to 7,054. Now we need to add a multiple of 10. so a number that ends in a 0, to a 4-digit number. And we can do that using what we know about place value, so without using column addition. First, we have 8,054 plus 50. So if we highlight our tens digits, we have 5 plus 5. But that makes 10, which is a 2-digit number, and we can only have 1 digit in each place value. So what we need to do is highlight our hundreds digit as well, because if adding our tens gives us a 2-digit number, the hundreds digit also changes. So now we have 0, 5, which is just the same as 5, plus 5. So we can change these digits that we've highlighted to 10, so to 1 and 0, and leave our other digits the same. So our answer is 8,104. Now 7,383 plus 40. If we highlight our tens digits, we have 8 plus 4, but again, that's a 2-digit number. That makes 12. So instead, like we did here, let's highlight our hundreds digit as well. That means we have 38 plus 4, which is 42. So these digits are going to change to a 4 and a 2, and our other digits will stay the same. So we get 7,423. Now 3,979 plus 50. If we highlight our tens digits, that gives us a 2-digit number. But then, if we highlight our hundreds digit as well, that gives us a 3-digit number, and we only have 2 digits highlighted. 97 plus 5 is 103, but we've only highlighted 2 digits. So we need to highlight our thousands digit as well. And you can either circle like I've done here, or you might want to highlight by underlining. But really, we need to work out 397 plus 5. That's 402. So you can see that in our answer, the digits that we've highlighted change to a 4, 0 and 2. And then, as always when we're adding tens, the ones digit stays the same. Now 2,996 plus 70. Again, we need to highlight not just our tens digit, but our hundreds and our thousands digit as well. 299 plus 7 is 306, so we have that in our answer, followed by the ones digit that stays the same. Now let's show base 10 blocks so we can see why this method works for the questions that we've done. So for our first question, we started with 8,054, so that's 8 thousands, no hundreds, 5 tens and 4 ones. We were adding 50, so that's 5 tens. We can add 1, 2, 3, 4, 5 tens, but doing that means that we now have 10 tens, and we can exchange those 10 tens for 1 extra 100. So now we have 100 and 0 tens in our answer. Or, showing the same question using place value counters, we start with 8,054, but if we add 5 tens, because we now have 10 tens, we exchange those for 100, and again, that's why we have 100 and 0 tens in our answer, 0 tens even though we were adding tens. For our next question, we started with 7,383. We were adding 40, so that's 4 tens. We can add 1, 2 tens, then exchange, then add 3, 4 tens, so that's why in our answer we get 4 hundreds, because we've made this 100 here by exchanging, and we now have 2 tens. Or with place value counters, we started with 8 tens, we added 1, 2, then we exchanged, then added 3, 4. So you can see why it's the hundreds digit as well as the tens digit that has changed in our answer. Then 3,996 and 79. We can add 1, 2, 3 tens, exchange again because 10 hundreds make 1 extra 1,000, and then we can add our 4th and 5th 10 so that we've added 5 tens altogether. Now you can see that we've made an extra 1,000. We now don't have any hundreds because we exchanged those for the extra 1,000, and we have 2 tens. Or using place value counters, we can start with 3 thousands, 9 hundreds, 7 tens, and 9 ones, and we're adding 5 tens, so we can add 1, 2, 3, exchange again, and then add our 4th and 5th 10. So that leaves us with 4 thousands, no hundreds, 2 tens, and of course we still have our 9 ones. Then we had 2,996, so there's 2 thousands, 9 hundreds, 9 tens, and 6 ones, and we were adding 70, so 7 tens. But if we add just 1 10, that means that we have 10 tens, so we exchange. But now we have 10 hundreds, so we exchange those for 1 more 1,000. So remember, that was just adding 1 10, and we need to add 7. So if we add another 6 tens, that means that we've added 7 tens altogether to give us 3,066, because we've got 3 thousands now that we've exchanged, no hundreds, 6 tens, and we still have our 6 ones. Or, using place value counters, you can see that adding just 1 10 means that we have 10 tens which we can exchange for 100, but doing that means we exchange 10 hundreds for 1 extra 1,000. And that was adding just 1 10, so if we add another 6, you can see that we now have 3 thousands, no hundreds, 6 tens, and 6 ones, so that's why our answer is 3,066. That's why adding tens can sometimes cause not just the tens digit, but the hundreds and even the thousands digit to change as well. For these questions, we need to add 2 multiples of 100, so 2 numbers that both end in 2 zeros. First, we have 900 plus 300. If we highlight our hundreds digits, 9 plus 3 is 12. So our answer is 1,200, because 9 plus 3 is 12, and when we're adding multiples of 100, our answer will also be a multiple of 100, so the zeros on the end stay the same. Now 800 plus 600. We know that 8 plus 6 is 14, and that means that 800 plus 600 is 1,400. Again, the 2 zeros on the end stay the same in our answer. Now we have 1,700 plus 300. So we need to be careful with this question to make sure that it's the hundreds digit that we're highlighting. So we start with 7 hundreds and we're adding 3 hundreds, but that would give us 10 hundreds, which is the same as 1,000. So what we need to do, because 7 plus 3 is 10, but that's a 2-digit number and we've only got 1 digit highlighted, we need to highlight our thousands digit as well. Now 17 plus 3 is 20, so our answer is 2,000. 17 plus 3 is 20, and again the 2 zeros on the end stay the same. 5,500 plus 800. If we highlight the hundreds digits, 5 plus 8 is 13. But because that's a 2-digit number and we can only have 1 digit in each place value, we highlight our thousands digit as well, and 55 plus 8 is 63, which means our answer is 6,300 because the zeros on the end stay the same. So let's take a look at these questions to see what was happening. For this first one, we started with 900 and we needed to add 300. But adding just one more 100 gives us 10 hundreds, which we can exchange for 1000. So that was adding 100. So if we add 2, 3, you can see that because we've added 3 hundreds, we have 1000 and 2 hundreds in our answer, and of course we don't have any tens or ones. Or using place value counters, if we start with 900 counters, adding just one more 100 means we have 10 hundreds, which we can exchange for 1000. So then we just add our second and third 100, which means we have 1000 and 2 hundreds in our answer. Then we had 800 plus 600. We can add 1, 2, exchange, then add 3, 4, 5, 6 hundreds to give us 1400 as our answer. Or with place value counters, again, we can add 1, 2, exchange, then add 3, 4, 5, 6. Then we had 1700 plus 300. If we add 3 hundreds, that gives us 10 hundreds, but we can exchange 10 hundreds for 1 extra 1000, meaning that we get 2000 as our answer. With place value counters, again, if we start with 1000 and 700s, adding 3 hundreds means we get 10 hundreds, which we can exchange for an extra 1000. And then for our last question, we started with 5500. We were adding 800, so we can add 1, 2, 3, 4, 5, exchange, then add 6, 7, 8 to give us 6300 as our answer. Or with place value counters, again, we can just add 1, 2, 3, 4, 5, exchange, then add 6, 7, 8 to give us 6300. Now we need to count on in hundreds from a 4-digit number. So here we start with 6132. So we can see 6 thousands, 100, 3 tens and 2 ones. If we're counting on in hundreds, we're adding 100 each time. So next we have 6232, 6332, and we can keep on counting in hundreds. So now we've got to 6932. We've got 6 thousands, 900s, and we've still got 3 tens and 2 ones. Notice, because we're adding hundreds, the tens and ones always stay the same. But then, if we add another 100, we get 7032. That's because we've now got 10 hundreds. But when we get 10 hundreds, we can exchange those for 1 extra 1000. And when we do that, you can see that we now have 7 thousands, 0 hundreds, and of course we still have our 3 tens and 2 ones. We can show the same sequence but using place value counters instead. So we start with 6132 and we can add 100 counter each time. But then once we've got 10 100 counters, we exchange those for 1 extra 1000 counters. And that's why, in the end, we get 7 thousands and 0 hundreds. So now, let's count in hundreds from 4555. So we can see 4 thousands, 500s, 5 tens, and 5 ones. Then we have 4655, 4755, and then if we keep on counting in hundreds, after 4,955, we will have 5,055. That's because now that we've got 10 hundreds, we can exchange those for one extra thousand. So notice, when we're counting in hundreds, the tens and ones digits will always stay the same. But if we ignore our tens and ones digits, we can see that counting in hundreds is just like counting in ones. We have 45, 46, 47, 48, 49, and 50. So if we keep on counting in hundreds, adding 100 each time, that takes us to 5,455. We can show the counting using place value counters as well. So we start with 4,555, and by counting in hundreds, what we're doing is adding 100 each time. But then, once we've got 10 hundreds, we need to exchange those for one extra thousand, because we can only have one digit in each place value column. Once we've done that, we can keep on adding hundreds until we get to 5,455. Now we need to add a multiple of 100, so a number that ends in two zeros, to a 4-digit number. First, we have 1,244 plus 500. So because we're only adding hundreds, not adding tens or ones, what we can do is highlight our hundreds digits. Here we have 2 hundreds and we're adding 5 hundreds. So in our answer, we'll have 7 hundreds, and all of the other digits in the number that we started with will stay the same. So our answer is 1,744. Now let's try 3,539 plus 500. This time, when we highlight our hundreds digits, we have 5 plus 5. But that makes 10, which is a 2-digit number, and we can only have one digit in each place value. We can't write 10 in our hundreds place. Instead, what we need to do is look to the left and highlight our thousands digit as well, because if we have 10 hundreds, that will make an extra 1,000, so we know that the thousands digit has to change. Now, 35 plus 5 is 40. So our answer is 4,039, because 35 plus 5 is 40, and then because we're not adding any tens or ones, the tens and ones in the number that we started with stay the same. Now 5,381 plus 800. We can highlight our hundreds digits, but 3 plus 8 is 11, and that's a 2-digit number. But because we can only have one digit in each place value, we look to the left and highlight our thousands digit as well. 53 plus 8 is 61. So our answer is 6,181, again with our tens and ones staying the same. Finally, we have 3,855 plus 800. We can see 8 plus 8 is 16, so we highlight our thousands digit as well. And here I've highlighted by circling, but you might prefer to highlight the digits in the question by underlining and then seeing what you need to do. Now 38 plus 8 is 46, so our answer is 4,655, with the tens and ones staying the same, because we're adding a multiple of 100, so not adding any tens or ones. So if we look back to this first question, we started with 1,244, so 4 tens and 4 ones. We were adding 500, so when we add 1, 2, 3, 4, 5 hundreds, we can see that the only thing that's changed is the number of hundreds we have. We now have 7 hundreds, so only that digit changes in this first question. Or if we show place value counters, again we're starting with 1,244 and 44, and because we're adding 500, all we need to add is 500 counters, and that gives us 1,744 as our answer. But for our next question, remember the thousands digit needed to change as well. So for this question, we started with 3,539. If we add 500s, let's add 1, 2, 3, 4, 5. That gives us 4,039 because we've now got 10 hundreds. But when we get 10 hundreds, we need to exchange those for one extra thousand, and that means in our answer we have 4 thousands and 0 hundreds. Or using place value counters, we can see if we start with 3,539 and add 500 counters, we can exchange those for one extra thousand, giving us 4 thousands and 0 hundreds in our answer. And of course our tens and ones have stayed the same because we're not adding tens or ones, we're only adding hundreds here. Now we start with 5,381 and we need to add 800. So if we add 1, 2, 3, 4, 5, 6, 7 hundreds, we now have 10 hundreds, so can exchange those for one extra thousand. And then, because we've only added 7 hundreds, we need to add one more hundred, so that we've added 8 hundreds altogether. So that's why, in our answer, we now have 6 thousands and 100, and of course the 8 tens and 1 1 have stayed the same. Or, using place value counters, again we're starting with 5,381. Let's add 800 counters. We can add 1, 2, 3, 4, 5, 6, 7, exchange, then add 8 to give us 6,000 counters and 100 counter. And finally, we have 3,855. We need to add 800s, but if we add 1 200s, we can then exchange the 10 hundreds we have for one extra thousand. Then we can add 3, 4, 5, 6, 7, 8 hundreds, and you can see that now in our answer we have 4 thousands and 6 hundreds. Or with place value counters, we're adding 8 hundreds, so we can add 1, 2, exchange, then add 3, 4, 5, 6, 7, 8 to give us 4 thousands and 6 hundreds in our answer. Now we need to add using column addition. First, we have 2,839 plus 86. So we write the question out like this, with the digits lined up on the right hand side. So with the 6 underneath the 9 and the 8 underneath the 3, because that way our place value columns are lined up. So we have our ones column, our tens, our hundreds and our thousands. So we line the digits up on the right hand side, and then we start by working from right to left, so adding our ones. 9 plus 6 is 15, so we write that 1, 5, with the first digit above the next place value column along. 1 plus 3 plus 8 is 12, that's 1, 2. 1 plus 8 is 9, and 2 plus nothing is 2. So our answer is 2,925. Now 2,424 plus 909. Again, we've got the question written out with the digits lined up on the right hand side, because when we're adding whole numbers, if the digits are lined up on the right, then our place value columns will be lined up as well. That is with whole numbers. Remember, with decimals, it's the decimal point that you need to line up. But here, because we've got whole numbers, we've lined them up on the right hand side, and that means our ones, tens, hundreds and thousands columns are lined up as well. Now, 4 plus 9 is 13, so that's 1, 3. 1 plus 2 plus 0 is 3. 4 plus 9 is 13, so 1, 3. And 1 plus 2 is 3. That gives us 3,333. 856 plus 567. 6 plus 7 is 13, so 1, 3. 1 plus 5 plus 6 is 12, so 1, 2. And 1 plus 8 plus 5 is 14. Now normally, if we get a 2-digit answer, we write the first digit above the next place value column along. But here, we don't have any more digits to add. So we can just write our answer in our answer line. 1 plus 8 plus 5 is 14, so we can write that in our answer because there are no further digits to the left. So that gives us 1,423. Finally, let's look at 3,867 plus 2,536. 7 plus 6 is 13, so 1, 3. 1 plus 6 plus 3 is 10, that's 1, 0. 1 plus 8 plus 5 is 14, that's 1, 4. And 1 plus 3 plus 2 is 6, so our answer is 6,403. Now let's take a look at these questions a bit more closely. And what we can do is show base 10 blocks to make it clear why this method works. So why we need to line up our place values, why we write the first digit of a 2-digit answer above the next place value column along. So for this first question, we started with 2,839. So that's 2 thousands, 800s, 3 tens and 9 ones. Remember, we work from right to left, so we started by adding 6 ones. But remember, when we've got 10 ones, we can exchange those for 1 10. So to add 6, we can add 1, exchange, then add 2, 3, 4, 5, 6. And you can see that we've made 1 extra 10, so that's why we write 1 above our tens column, and we've got 5 ones. So now we need to add 8 tens. But remember, when we get to 10 tens, we can exchange those for 100. So we can add 1, 2, 3, 4, 5, 6, exchange, then add 7, 8. And you can see that by doing that, we've made 1 extra 100, so that's why we write 1 above our hundreds column, and we've got 2 tens, so 2 tens to go in our answer. And we've now got 9 hundreds because we need to add the 1 that we made from adding our tens, and we've still got 2 thousands. We can also show the addition using place value counters. So we start by adding 6 ones, but remember when we've got 10 we exchange. So we add 1, exchange, then add 2, 3, 4, 5, 6. Then we add 8 tens, and remember again, when we've got 10 tens, we can exchange those for 100. So we can add 1, 2, 3, 4, 5, 6, exchange, then add 7, 8. So that gives us 2,925 as our answer. Then we started with 2,424 and we were adding 909. First we add 9 ones, 1, 2, 3, 4, 5, 6. Then we can exchange, then add 7, 8, 9. So doing that means we've made 1 extra 10 and we have 3 ones, so that's the ones digit of our answer. Now we have 1 plus 2 tens and we're not adding any tens, so we have 3 tens in our answer, 2 that we started with and 1 that we've made by adding our ones. Then we need to add 9 hundreds. But remember, once we get 10 hundreds, we can exchange those for 1 extra 1,000. So we can add 1, 2, 3, 4, 5, 6, exchange, then add 7, 8, 9, and now, because we've made an extra 1,000, that's why we write 1 above our thousands place value column, and then we've got 3 hundreds in our answer, and because we weren't adding any more thousands, we've got our 3 thousands as well. Or using place value counters, remember we start by working from right to left, so we start by adding our 9 ones. 1, 2, 3, 4, 5, 6, exchange, 7, 8, 9. Then we weren't adding any tens, but we were adding 9 hundreds. We can add 1, 2, 3, 4, 5, 6, exchange, then add 7, 8, 9, and you can see that we have 3,333. Now we have 856, and we were adding 567, so let's start by adding 7 ones. 1, 2, 3, 4, exchange, 5, 6, 7. So we've made 110, and then we've got 3 ones in our answer. Now we can add 6 tens. 1, 2, 3, 4, exchange, 5, 6, so we've made 1 extra 100 and we have 2 tens in our answer. So now we need to add 5 hundreds. But remember, when we get 10 hundreds, we can exchange those for 1,000. So we can add 100, then exchange because that gives us 10, then add 2, 3, 4, 5, and you can see that we now have 1,400s in our answer. Or using place value counters, remember we start by adding 7 ones. 1, 2, 3, 4, exchange, 5, 6, 7. Then we can add 6 tens. 1, 2, 3, 4, exchange, 5, 6, and then we add 5 hundreds. 1, exchange, 2, 3, 4, 5. So that gives us 1,423. And finally, let's take a look at 3,867 plus 2,536. First, let's add our 6 ones. 1, 2, 3, 4, 5, 6. Now we can add our 3 tens. 1, 2, 3. But that gives us 10 tens, so we exchange those for 100, which is why we have 0 tens in our answer line. Now we add 5 hundreds, so we can add 1, exchange because we've now got 10, then add 2, 3, 4, 5. And finally, we just need to add 2 thousands. There's 1, 2 thousands, and that gives us 6,403. Or using place value counters, first we add 6 ones. 1, 2, 3, exchange, 4, 5, 6. Then 3 tens, so 1, 2, 3. And now, because we've got 10 tens, we can exchange those for 100, and that leaves us with 0 tens in our answer. Now we need to add 5 hundreds. 1, exchange, 2, 3, 4, 5, and then we add 2 thousands. So that gives us 6,403.